Take a look at the beginning of linear equations that involve two variables. Last class we took a look at the equations, but we didn't actually think of them as linear functions. We just said equations in two variables. We're calling them linear now because they behave in a linear trend. We're going to see that this chapter, or mainly this chapter in 3, we're going to look at data that behaves with some sort of a constant slope throughout. If the slope is not constant, then the data is not linear. And Mr. Hall says the same thing, we both say this every year because he teaches the other section, we both always say that if there's one of 3 things that you need to know by the end of your algebra in high school, it's linear functions. Linear functions, quadratic functions are the 2 functions that you should have down pat, like the back of your hand. Okay, this is definitely one of those big things. The second objective is to take a look at vertical and horizontal lines and those equations, which behave differently than a line that has some sort of a slope to it. And then finally, take a look at graphing a pair of linear equations to locate the intersection of those two. Take a look at draw a graph of the equation here by plotting points. So, I'm assuming that people know how to plot points. We already did this last class. We already talked about getting the table of values. So, what I'm going to do right now, just for the sake of time for today, is say, okay, you know what I would do is I would start with this. I'd move the 2x over by subtracting it, or just put negative 2x in the front. And then I'd make a table. So I'm going to make a table for you right now just to save some time. I'm going to use negative 2, negative 1, 0, 1, and 2. Just to be around the origin or around the y-axis, symmetrically. The coordinates in the y-axis, or the corresponding y values, will be 11, 9, 7, 5, and 3. Now I know we didn't talk about it yet, but who can explain from last year their knowledge? How come you could have continued this table without even knowing any other points? Like from 11 to 9, I could have given you the rest without even typing in my calculator. How could I have predicted 7, 5, and 3?
Because the slope is negative 2.
Yeah. A lot of you know from last year, you've learned about this already. We're going to see it in the next sections or so. Negative 2 is the slope. So if x changes by 1, right? These are increasing by 1. Y has to go down by 2. Because it's change in y over change in x. The change in y is negative 2 every time. The change in x is positive 1. Negative 2 over positive 1 is what the slope is really here. Okay, but for now, I'm assuming you didn't know that, so I said plot by points. So we have our graph here. I highly recommend that you download a template of graph paper on your iPad if you haven't done it already, or in Notability, you could at least use the graph paper on the background. I don't know if that works, though, on PDFs. It might overlay it, so you might not be able to do that. Under Settings and Notability, this little wrench in the top right, you can choose graph paper, but I think it might put that over my notes, or I don't know if it actually works. Does it overlay it properly?
You can add a sticky note of graph paper.
That's the one, yeah, perfect. Add the sticky note, it's a little plus symbol right at the top. So add the sticky note and choose graph paper every time. Thanks, Daniela, smart. So if I'm going to graph this, my x-coordinates only change, I shouldn't say range, the domain of this function. Clearly here, I'm looking from negative 2 to positive 2. It's a continuous function throughout, but I'm specifically looking at those domain values. So along the x-axis, I'm simply going to use those for now. How about the y-axis? Where am I really zooming in on in this problem? Why am I doing this? Watch what I'm doing right now. I just erased my y-axis and went like this. Who can explain why I just reoriented my graph just now? A lot of this is about number sense, right, Em?
Is it because all the numbers are positive, so you don't need the line in the bottom?
Exactly right, Em. Look at your y values. They're all positives. So you don't need negative y values. So why focus on those quadrants? Focus on the first and second quadrants only. And as a result, we can take a look and see negative 2, 11 is at the top. So you know what I'm going to do? I'm just going to plot 5 and 10. Okay, I'm just sketching this so it's my notes, so I don't really care. So there's the negative 2, 11, negative 1, 9, 0, 7, 1, 5, and 2, 3. Okay, and I'm going to see that these behave in a linear fashion. So that's why you're using your sticky notes, right? So your graph doesn't look ugly like mine does right now because I'm sketching. If you're using that sticky note with a little grid on it, your graph will look linear, right? That looks like it's a little bit skewed up because of the fact that I wasn't using grid lines there. So please use grid lines on your own when you do this. Okay, so grab that sticky note, insert a sticky note there with the graph. or just save a graph image, okay? I'll do that for the next one. I'll import a graph so you can see a little bit better. Any questions on this? What did I forget to label? What else should I label?
X and Y.
Yeah, please label your axes, X and Y. Okay, label whatever they are. The reason labels are so pushed on you when you're younger is because real life graphs have labels. Think about a graph with no label in real life. What significance does it have to anything? You have no idea. It makes no sense. If I'm looking in the Newsday and I see this graph of something with economics that I'm interested in, imagine if there's no labels at all. What the heck do numbers mean without labels, right? Without units, without labels, they mean nothing. So get used to labeling your axes so you understand the significance of the graph. Graphing by intercept, that you may or may not have done in middle school. It's probably one of the easiest ways to graph lines. I think it's easier than graphing using slope-intercept. Using, y equals mx plus b, which is what you always learn, because you learn that for a reason. It makes sense, because the concept of slope and y-intercept occurs naturally in everyday life with applications. Like think about like anything. You start with a certain amount of money, and then it increases every day. That's a linear function. Now we're going to do this though by graphing with intercepts. And think about it logically. If I told you, right, if I said that the y-intercept was 7, the y-intercept is 7, what's the coordinate really? I should say the value of the y-intercept is 7. What's the coordinate that represents that? What's the coordinate?
0, 7.
0, 7. Right, that's like a y-intercept, for example. An example of an x-intercept would be 6, 0. Well, recognize something. And this is something that every year some students still have struggles with. If the y-intercept has x as 0, and the x-intercept has y as 0, and this always happens, you could find these intercepts by just setting 0 equal to one of them in the equation. So we're going to look at the equation, and when we want to find the y-intercept, just set x to 0. And when we want to find the x-intercept, set y equal to 0. And that's what this says up here. Okay, it's probably one of the most important things you're going to have to learn. And it continuously happens. This works for quadratics, for cubics, for any function. If you want the x-intercept, set y to 0. If you want the y-intercept, set x to 0. It's not going to go away. You're going to continue to use this notion throughout the next 3 years of math. So we're going to do an example of this now. Take a look at this. If I could come up with just the intercepts, why does it make it easy for me to graph? If I want to make a line, what do I need? To make a line, I need 2 points. That's it. Any 2 points on the graph satisfy it. So find the intercepts. They're really easy. When it's written in standard form, right? Do we know the term standard form? We're going to talk about it later. But standard form is this. Okay, not slope-intercept form, which is y equals mx plus b. When it's in standard form, it makes sense to find the intercepts. Because you know what you can do? Watch. Just simply, I'm going to make this arrow a hand. Cover this up. Put your hand over this. That's my hand covering it up. Okay, cover up the 2x. That pretty much is telling me set x equal to 0, right? When I cover this up, I'm saying put a 0 in for x. This whole thing drops off. So I do this. I literally just make that go to 0, and that gives me the y-intercept. Divide by -3, y equals 3, which gives me 0, 3. That's my y-intercept right there. How do I know it's 0, 3? Because this went in for x. That was x is 0. That's the 0 right there. And we got y as 3 as an answer. And then the same thing for x. Okay, set y equal to 0 by drawing that, crossing it off, and then dividing by 2. Okay, remember, the negative sign is attached to the 3. So this negative sign right here is attached to the 3. So this goes away when you set it equal to 0. So it's just positive 2x equals -9. So x equals -4.5. Those are my intercepts. So please simply graph the intercepts and connect them. That's all you have to do to solve, or to graph this. Just pull out my graph paper real quick. Okay, so quickly graph. You have your y-axis here. You have your x-axis here. Your x-intercept was negative 4.5. I'm going to go by ones in this graph. My y-intercept was, what was the y-intercept again? Just positive 3. Okay, so that's right here. The x-intercept is at negative 4.5. There's 1, 2, 3, 4, 4.5. Right there. Simply connect these 2 points. Okay? There's our linear function. Make sense? So graphing by intercept method. You graph both intercepts and simply connect them. Questions on this so far? Yeah? All right, good. Intercept method, some students never learn in middle school, some do, so I just want to go over it. This might be new. It's possible that it's reviewed for some of you, but it might be new for others. Graph the following. And I'm calling these horizontal lines and vertical lines, but horizontal line I call a constant function. So, what does it mean if y is equal to 5? Well, here's what it really means. Ready? For part A, it really means 0x plus y is equal to 5. That's what it really means. Christian, give me a value of x. Any value. Pick. 2. All right, I'm going to plug a 2 in here. What does y become? Y becomes 5, doesn't it? Because 0 times 2 is 0, so y is 5. Morgan, give me another value for x. 4. All right, I'm going to plug a 4 in here. When I plug a 4 in, what happens? What's y again? Whoops. Whoops, whoops. What is y again? 5. So no matter what value you pick for x, y is always 5, right? So that's why the equation says y equals 5. So if I think about that logically, pick a value for x. So I go over, I'm going to go over 2 for x equals 2, and here's the coordinate up at 5. I go over 4, it's up at 5. I go over 8, it's up at 5. 0 is up at 5. No matter what, it's always at 5. Whoops. It's always at 5. Connect these dots, it is a horizontal line. So, y equals some number is a horizontal line and also known as a constant function. What do I mean by constant function? It's never changing. Okay? It's steady. It's flat. It has no incline. It's not increasing or decreasing. It's a constant value of y equals 5. That's awesome. Soap, you guys making this in bio? Or is this the soap making class? It smells so good. It's vanilla. All right. Sorry, sidetrack. The second part, x equals negative 7 halves. What's negative 7 halves as a decimal? Negative 3.5. So if that helps you, please rewrite it. Because you know what? A lot of people think of that as a slope because they see the fractional portion. What kind of a line do you think this will be? Give me another minute. I know the bell rang. What kind of a line do you think this will be? Yeah, vertical line. And this one, instead of going through 5, is going to go through negative 3.5. So I go back to negative 3.5, and I put an infinite amount of dots above and below each other, and it connects to be a vertical line. This is not a function, and it's not called a constant function, and I'll explain why that is. Examples 4 and 5 are not difficult. Please either do one of two things. Look at my notes and go through them on your own, or watch the video under Mr. Howell's videos for examples 4 and 5. Okay? Please look at those tonight. Your homework is listed at the bottom. Make sure to get that done, please.